Hello and welcome. This lesson focuses on interoperability in the context of cloud computing. By the end of this lesson, learners should be able to understand the concept of cloud computing in the context of interoperability, understand the benefits of the cloud environment, interoperability and cloud computing. In the context of cloud computing, interoperability is viewed as the capability of public clouds, private clouds, and other diverse healthcare systems to understand each other's application and service interfaces, configuration, forms of authentication and authorization, and data formats in order to cooperate and interoperate with each other. In most cases, healthcare data, whether in text, note, number, image, formula, date, or other unstructured form, is being created faster than it can be processed. The cloud holds great potential as the medium by which this data can move and be exchanged. Its proven proficiency at breaking down barriers to massive amounts of centralized, unstructured data, big data, if you will, makes it a data access and exchange enabler. If we can break down data silos in a way that protects the privacy and security of each patient's data, business insight and improved health outcomes can be achieved more efficiently, and healthcare executives can begin to explore use cases that have yet to be contemplated. In contrast, where data exists inside silos, in an on-premise physical environment that's not built to enable secure access and sharing, for example, providers have lost an opportunity to achieve patient outcomes, comply with current and dynamic standards, and compete on the innovation necessary to succeed in the new consumer-centric healthcare environment. But simply porting data, whether clinical health data in an EHR, protected health information, PHI, or financial data in a financial management system, to the cloud and enjoying its benefits won't happen overnight. Due to competitive considerations and confidentiality risks, there must be a level of trust in the quality and security of the receiving organization's health data management systems for the data owner to be willing to share it. No one wants to risk a HIPAA privacy or security violation at the hands of another entity, whether a coordinated care provider or a third-party IT solutions vendor. To a lesser degree, ubiquitous cloud interoperability in healthcare will also require further development and adoption of common data standards and protocols and architectures. In simplest form, cloud integration is the process of configuring multiple application programs to share data in the cloud. In a network that incorporates cloud integration, diverse applications communicate either directly or through third-party software. The cloud still uses APIs, application program interfaces, and integration methods. It simply enables them to work in a common, scalable, and low-cost computing environment. As application-to-application integration continues to evolve, common languages, interfaces, and subsystems are showing signs of increased convergence. For example, FHIR, Fast Healthcare Interoperability Resources, is the latest standard to be developed under the HL7 organization, combining the best features of HL7v2, HL7v3, and CDA, clinical document architecture, while leveraging RESTful web services in a canonical data model, a design pattern used to communicate between different data formats. In contrast to the majority of Exchange profiles based on SOAP web services, RESTful web services enable basic HTTP operations including create, read, update, and delete functionality. But, to extend these functions beyond the individual facility to the greater healthcare community, the healthcare providers and IT solutions providers that use these advanced protocols and architectures also need a purpose-built data environment that facilitates the approach. Proprietary ERP-like systems designed for use within a single organization's four walls are not that environment. The cloud environment, on the other hand, offers the advantages of real-time, secure access to virtually any data format using highly elastic compute, bandwidth, and storage capacities that are based on the needs and demands of the use case. This concludes the lesson, Cloud Computing and Interoperability. Thank you for watching.